In section 9.3, we're going to be talking about geometric sequences. So in a geometric sequence, you're starting with a value a and a common ratio r, and you have a sequence of the form. You start with a, then you go to a times r, then a times r again, then times r again, and that's how the pattern's going to go. So it's similar to an arithmetic sequence, but instead of adding a number every time, we're multiplying some common number every time. And we can kind of simplify this to a times r squared, and then our fourth term would be a times r cubed. So you can kind of maybe see the pattern a little bit better this way. And again, we can make a recursive and an explicit definition for a geometric sequence. A recursive definition would look like this. We start with our first term, a1 equals a, and then our nth term is our previous term, a n minus 1, times our common ratio r. An explicit definition would look something like this. Our a to the nth term would be a1 times r to the n minus 1 power. And notice here that n minus 1 power kind of makes sense because looking at this pattern, going from our first to our second term, we're doing r to the first power, our third term's r to the second power, fourth term's r to the third power. So each time you're multiplying r, it's like one behind your term in a way. So first, let's just work on identifying a geometric sequence. Is the sequence geometric? If so, what is our first term in our r value? So remember here, similar to when we did arithmetic sequences, we were looking for a very specific kind of pattern, specifically if we were adding a number every time. Here we're looking if we're multiplying a number every time. So in our first sequence, we have 3, 6, 12, 24, 48, moving on from there. Now this one might seem pretty obvious, but just to kind of go through the long way, if a sequence isn't as obvious if it's geometric, how you could check each time is by taking a term and dividing it by its previous term. If you do that for each consecutive terms in the sequence, that's going to check to see if there's a common ratio. So in this problem, if I want to check to see if there's a common ratio, I would check to see if 6 over 3 is equal to 12 over 6, is equal to 24 over 12, is equal to 48 over 24. Here, when I simplify all those fractions, I see that it's 2 every single time. So I'm multiplying by 2 every time in this pattern. So yes, it would be geometric. My first term is 3, and my common ratio r is 2. In my second sequence, we're going from 3 to 6 to 9 to 12 to 15. So again, looking at this, I might see, oh, okay, I can kind of think of a pattern here. But remember, I'm checking to see if I'm multiplying by a common number every time. And again, how I could check, I want to see if 6 over 3 equals 9 over 6 equals 12 over 9 equals 15 over 12. I can see that these do not equal each other, so no, this pattern is not geometric. Next, let's analyze a geometric sequence. What is the 10th term of the following geometric sequence? So I'm starting with 4, going to 12, going to 36, and I want to go and figure out what the 10th term is. So my first term here is 4, and my common ratio looks like it's 3. So that's really all that I need to be able to figure it out, and I'll use an explicit definition here because that's usually going to be the easier one to work with. So I'm going to be using the equation 4 times 3 to the n minus 1. I'm finding the 10th term, so in my calculator, I'm going to be doing 4 times 3 to the 9th power, and I'm going to find that that's 78,732, and that's my answer. Now, similar to what we did for arithmetic sequences, let's find the second and third terms of this sequence. So I start with 2. I don't know my second, I don't know my third term, and I know that my fourth term gets us to negative 54. So again, my a1 value is 2. To get to negative 54, I know that my fourth term is 2 times some number r, times some number r, times some number r again, and it gets me to negative 54. So this is how I could set up an equation to find r. So the key here is, again, I'm trying to just figure out what that common ratio is. That's the key to figuring out these numbers. I can't necessarily use an explicit or recursive definition because I don't know that r value. I need to solve for r. So to solve for r here, I have negative 54 equals 2 times r to the third power, and I want to solve for r. So I'm going to divide 2 on both sides. I have negative 27 equals r cubed. I'm going to take the cube root on both sides, and the only value that I could get here is negative 3. So the cube root of negative 27 is negative 3. So that's my common ratio. 2 times negative 3 will give me my second term. That's negative 6. Negative 6 times negative 3 gives me my third term, which is 18. And then just to double check, 18 times negative 54 or 18 times negative 3 would in fact give me negative 54. So I know that this all checks out. And these are my final answers for my second and third term. Kind of the last main topic we're going to go over here is the geometric mean. So the geometric mean of any two positive numbers x and y is the square root of x and y. So kind of similar to the arithmetic mean where I added two numbers and divided them to find the middle number between them. Here for a geometric mean, for a geometric sequence, I multiply the two numbers together and take the square root. And this only works with two positive numbers because I can't take the square root of a negative number. So what are the possible values of the missing term of the geometric sequence 48 blank 3? So what I'll do here is I'm going to take the square root of 48 and 3, which would give me the square root of 144, which could give me positive or negative 12. Now both of these could work as an answer because let's say that my common ratio is negative 1/4. When I go here, if it's negative 1/4, I would get negative 12. If my common ratio is positive 1/4, I would get positive 12. And then negative 1/4 again, positive 1/4 here. Those would both get me to 3. So those are two possible values. I don't really know enough to whether my common ratio would be giving me negative numbers or positive numbers every time. So that's why my answer could be positive 12 or negative 12.